All right. So thanks for everybody who's joined in. If you have any questions at any time, you can unmute. It kind of brings you in as muted. And if it's not letting you do that, let me know. I think there might be a setting I can go in and change. Let's see, where would it be? Can someone try to unmute for me and let me know if they're able to talk?
Can you hear me? Hello.
If it's not letting you, let me know in the chat.
I can hear you, Will. I don't know if he can.
Oh, okay.
No one? Okay. Well, hopefully if you want to, you're able to unmute. If not, I'll kind of keep an eye on this chat. Oh, you can hear each other? Okay. Let me see. I haven't used this in a hot second. I think this is just my audio settings. Mute my microphone. Let me think. Oh. All right, now try. See if someone can unmute and talk to me.
Can you hear me now?
Yeah. Sorry.
All right,
I
cool.
have it turned off so things don't go off during class when we're using this to record. So, all right. So we'll kind of jump into where we left off. We'll go over a little bit today, some new topics, and then we'll probably look at that paper that I had posted and kind of think about some linear regression stuff. So we'll start out, we were talking about leagues and kind of their role in optimizing kind of overall demand for a sport. So one of the things that they're going to think about is league-wide advertising or promotion. And so you can think about, you see a commercial for upcoming games for whatever league it's in, that's all being paid for by the league. So certain games are going to be able to draw a wider fan base depending on the market size of the teams. But there's, however many games, 82 times 30 for NBA, right? Like how many games are in a season that they can promote. And some of them are going to be valued at a higher amount than others, but no one team is kind of paying for these national advertisements. So we would call them a public good in the sense that, if the league's just promoting the NBA and promoting its brand, once that's out there, once that advertising is out there, it's non-rival and non-exclusionary. So no team can be excluded from benefiting from it, but also multiple teams can benefit from it at the same time. If the NBA is promoting promoting the league, every single team values from that, right? And it doesn't prevent other teams from also, every team benefits from that, and it doesn't prevent other teams from benefiting it as well. So we might think about each one of these teams benefits differently. If we were able to, right, in order to pay for this league-wide advertising, the league would charge every team a different amount because it knows that the teams in the large market are going to bring in more dollars from that same advertisement than the benefit that's coming from these smaller market teams. But it's pretty hard to do, right? And so we would have this problem where, once that league-wide advertising is out there, or they know it's going to be paid for. If the league said it was going to charge every team how much it benefits, well, there's going to be an incentive to underreport how much I benefit so that I have to pay less in. And that incentive exists for every single team. And so we end up getting a much smaller reported amount of how much they're benefiting. The league then looks at the cost and said, well, we're running too many ads then, right? The cost is higher than the benefit. And so potentially we have this free rider problem where only the teams that all the teams that underreport are going to benefit, but they're not going to have to pay in as much as the teams that don't underreport. Okay. So we can think about, maybe I mandate something based off of actual revenue, although there's, would still be an incentive there to underreport revenues, but it might be a little bit harder for teams to do that, right? Or we could just default to an equal share, in which we know, there's no incentive now to under or over report. It's just that the large market teams are going to be paying in less than how much they're benefiting, and the smaller market teams are going to be paying in more. So what's one way the league can kind of determine what the optimal amount of advertising is going to be? So we know that small market teams are going to benefit less than large market teams. And so maybe we have an example like this. So we know that for every ad that's run for the league, like league-wide advertising, the 15 small market teams, right, are going to have an intercept of 10,000, large market 20,000, and we'll kind of assume for right now there's an equal number of large and small market teams, just so we can kind of understand what the differences would be between the two. Now, it's more of likely a continuum, right? But we'll just kind of create two groups here. And then for each of these teams, let's assume that the benefit is decreasing by $1,000 for each additional ad run. Okay. We then think about what is kind of league-wide demand for these league-wide advertisings, right? So we'll also kind of use the assumption that the cost for each one of these ads is $150,000. So what would the optimal quantity for the league be? So we'll kind of go through. I think I didn't leave a blank slide in here. Oops. What's this? So this should be pinned. Oh, because I can go to. Let's see. Try moving the pin. Let me try. Oh, I'm not sure why this one's showing up. Oh, because I must have accidentally been pinned. So what we have, what we're thinking about, is kind of the number of ads here on the x-axis, right? And there's going to be a certain kind of cost to those. So even if we start out assuming kind of this constant marginal cost, so we're saying that each additional ad is costing the league $150,000, right? And so, and it may be slightly increasing, right? Like different broadcast companies, there might be some that offer different prices than others, so it might be slightly increasing, but we'll assume it's constant for right now. So the way we're going to determine where the intercept is at, we said for small market or for large market teams and small market teams, I believe the intercepts were, did I say 10 and 20 or 15 and 20? 10 and 20, right? So for large market teams, 20,000, 10,000 minus 1,000 was kind of the slope. And kind of think about this as maybe the quantity times the quantity of ads. So for each additional ad, the kind of benefit, the marginal benefit, which represents our kind of demand curve, right, for the number of ads from each team, would be falling by $1,000, right, for each additional ad. Now, if we want league-wide demand, right, we know we've got 15 of these teams, and we've got 15 of these teams. Right? Excuse me. So really all we're going to do is when we think about aggregate demand, try to draw this down here just real quick. All right, if I have like here's a large and small market teams demand curve. Let's say there's only 2 teams in the league. League-wide demand curve would be when I'm adding, so we got large, small, and then league-wide demand, right? So we're just adding up those demand curves. So if these represent those demand curves, the marginal benefits, we'd basically be adding up 15 of these and 15 of these, and then add them all together. So if we think about here, what 10,000 times 15 would be 150,000 minus 15 times this. So we've got minus 15,000 times the quantity of the ads. Right? And then we have the same thing up here. Right? So it would be twice as high of an intercept, but it's falling at the same level. Right? And then we would add these together to get kind of league-wide demand. Should be what, 400,000 is going to be the intercept, and then 30,000 times the quantity of ads. Right? And so you can think about, right, if every team was losing 1,000 for each additional ad, then the league will be losing 30,000 if there's 30 teams. So now that we have kind of league-wide, and it's not 400, check my math here, 450, sorry about that. So we've got league-wide demand, and it starts at 450,000. And then it has this slope, right, where for each additional ad, kind of my slope there, I guess, is negative 30,000. So the optimal number of ads is going to be, remember, this is kind of league-wide demand or representing league-wide marginal benefit from running these ads. So the number of optimal ads that the league is going to choose is just simply going to be where that demand curve or the marginal benefit to the league hits the marginal cost of each one of these ads. Right? We kind of noticed similar to last class, and I had looking at the responses to the last online quiz, we're thinking about either the market for advertisements, or I think there I was looking at the optimal number of teams in the league. Really, a lot of these are going to be I'll answer the question in the chat in a second. A lot of these are all going to really just be determining the marginal benefits and the marginal costs in that market, and where those two hit will be kind of the optimal point. And yeah, so we are, right? So to go from here to here, it's like we're really adding, this represents for every large market team, but we have 15 of them. So we would like add this together 15 times. Another way of doing that is multiplying that by 15. That's where that 300,000 minus the 15,000 comes from. We then had each small market team. This kind of represented their marginal benefit, but there was 15 of them. So when we multiply that by 15, that's how I was getting this down here. Really what we would be doing is adding up each team's 15 of these plus 15 of these, but that mathematically is the same as multiplying those by 15 and then adding them. And so that's where that league-wide demand comes from. So from here, right, it's us getting used to a little bit more using actual equations. So I have an actual equation for aggregate demand now. So if I go up here, 450,000 minus 30,000 times the number of ads, right? This represents kind of the league-wide demand or league-wide marginal benefit. The optimal point will be where that is equal to the marginal cost, right? But the marginal cost of every single ad was just 150,000. Oops, I've got a constant marginal cost there, right? So 150,000. Okay. So from here, it's just a matter of doing a little bit of algebra. I subtract the 150 from both sides, or 150,000 from both sides. I add 30,000 QA to both sides. So I'm left with what? 300,000 is equal to 30,000 times the quantity of the number of ads. Divide both sides by that 30,000. I'd be left with the optimal quantity of ads here would be 10. Okay. So, I'll probably make this a little bit more simplistic. If I was to ask you on an exam or something, not quite as much, 15 times this, maybe I would only give you, let's assume that there's 3 or 4 teams in the league. Here's each one's, right? Because it's more likely that not all 15 large market teams have exactly this marginal benefit. It's like that each team would have a slightly different one. So I might give you like a smaller number of teams, like 3 or 4, and then all you're doing is adding up each team's demand curve or each team's marginal benefit curve to get league-wide marginal benefit. Once I have an equation for league-wide marginal benefit, especially if I'm keeping marginal cost constant, it's pretty easy to just set the marginal benefit equal to the marginal cost, a little bit of algebra to solve for that optimal quantity. Okay. Any questions on that before we keep moving here? It's probably a little bit more math than we've used up to this point, but I'm going to start kind of assigning equations to some of these, visual lines that we're thinking about for demand, marginal benefit, marginal cost. Okay with this? All right. So, some of the other things that we've seen leagues do, or looking at some of the non-traditional ones, like the English Football League. We look over, outside of the U.S., there's a lot of variation in market revenue or value for these teams. different countries have different regulations, right? And so, here's I just had a couple examples here. I'm not even sure all the exact details of all of these, but right, every country is going to have different kind of rules, and so these teams are going to, not be following kind of the same set of rules as opposed to the major sports leagues we look at in the U.S. Right? But we've seen revenue grow quite a bit with TV coverage for the English Football League, and really, it's created like a lot of additional competition. Think about there's more revenue to be made, more teams are going to kind of enter into the market and increase competition. Right? So one interesting difference with the European Soccer League compared to the major sport leagues we'll look at in the US is they kind of have these open leagues. And so what that means is that the league that you're in depends on your performance, right? So your performance of the year prior will determine what league you're in. So if you do, if you're successful in a lower league, you get promoted to the higher quality league, right? And then the worst teams in the higher quality league the following year would be in the lower quality league. So this is going to create some interesting incentives. We can think about how this would play out relative to if this didn't exist. So these incentives have pros and cons, right? So there's an incentive to win, to try to get into the better league if you're in the lower quality league. There's also an incentive to not take a year off if I'm in the higher quality league, because if I end up at the bottom, I'm going to get demoted, right? And being in the higher quality league, there's always going to be higher revenues that exist from belonging to that league as opposed to the lower quality league. Right? So you kind of think about the revenue from each win is going to increase, right? Because now winning that additional game increases the likelihood that I stay in that higher quality league, or increases the chances that I get promoted to that higher quality league, right? So the idea here is it's creating additional revenue for each win, which we can think about in that win market. And we just kind of review some of that. It won't look anything crazy here, but we're thinking about this league structure, and we're thinking about the number of wins that a team targets, and we can kind of use this constant marginal cost to simplify it a little bit. Whatever the team's kind of demand curve was before, right? That was kind of building in, all the revenues from every source that and how they were related to the number of wins. And we said kind of the profit maximization number of wins would be the marginal revenue is equal to the marginal cost for that number of wins. Well, if there's now an increased dollar amount attached to each win because of this now chance of getting promoted or demoted, it's essentially like they've just increased the demand and marginal revenue curves for the team such that it should increase, even if the teams don't change their type of win or profit maximizing behavior, should increase the number of expected wins that we would see for every single team, right? Because these incentives will exist for every single team. So the idea here is, maybe a team that was considering taking a year off to kind of restructure contracts, maybe wait for or try to target a good draft pick. This additional incentive to keep winning is going to prevent us from seeing as much tanking in these types of leagues, right? So, if we look at the European soccer leagues, the Champions League and the Premier League, we don't see tanking behaviors that we do in the NBA, NFL, sports where teams have an incentive to tank to get draft picks, and there's no disincentive, then you're not going to get demoted from the league. While it's here, even though even if they had a lottery draft structure where there was incentive to get a higher pick, there's always going to be this additional disincentive now to lose, or this additional incentive to win, right? So kind of preventing us from seeing as much tanking going on in that league. In fact, I've never, might be a decent project idea is to kind of compare and look at kind of the number of losses and then look at team behavior in the European soccer leagues relative to kind of our US professional leagues. So one problem with this is that if there's these huge additional revenues to be made, this represents my marginal cost. So my total cost, even if my marginal cost was constant, my total cost would be that marginal cost times the quantity, which is here the number of wins, right, that I'm targeting. So my total costs, right, are also going to increase because I'm now targeting a higher number of optimal wins. And I don't know why I wrote this on the wrong side of the W, sorry. So there's this huge incentive, which, leads to teams spending a higher amount of total dollars, right? Well, the problem is this is just a targeted number of wins, right? So even though I'm targeting a certain number of wins, if the season plays out and I end up not winning as many games due to a variety of factors that maybe I didn't account for, or injuries, something like that. Well, now I've paid these huge costs to target this higher number of wins, but I win a much lower amount and maybe I get demoted. Well, now I've spent all this money, I didn't get the realized revenues, and now I'm back in a league where it doesn't offer as high of revenues from winning the same number of games. Right? So the incentives are good in that it prevents tanking, it potentially improves the quality of play, but for those teams that happen to be at the very bottom or at the end of the season, potentially they have these huge total costs that they have now eaten into their profits, and now they're in a situation where it's going to be hard to get back into the higher quality league and obtain those higher revenues. Right? So I forget how long ago this was, but you can see some of even these higher quality teams kind of falling from the higher quality Premier League to the lower quality Champions League. Right? And I think I use this example specifically because I forget what they had spent a lot of money on player salaries that year, and so they kind of fell victim to this fact that it's still targeted number of wins, right? Or the expected number of wins. Another thing that what we see that the leagues do is instead of kind of a franchise versus a single entity. So all major sport leagues are franchises, right? And it's kind of like McDonald's, right? Different people open up a McDonald's, but it's all under the same franchise, right? So every team in the NBA is like one of those McDonald's establishments, and the McDonald's Corporation is like the league itself. Right? So that's how most sports operate, right? Is a franchise league, right? So once they are underneath the umbrella, though, those teams make individual decisions, right? Just like different McDonald's, they follow you have to follow corporate's certain guidelines, but there is some flexibility in what you can do. Right? Gas stations are like this as well. So teams can, once they're in the league, they can spend on local advertising or make local TV contracts, win versus profit maximization, right? They might be, their behaviors might not line up with every other team in the leagues in the sense that, they could choose to win maximize even if everybody else is profit maximizing, or vice versa. So there's still some independence from these teams. Single entity leagues are a little bit different, right? So every single owner of every team has a share of the league, right? And so league-wide decisions, right? If we've all got kind of a share in the league, right? We're going to try to make decisions that try to increase profits or, said differently, minimize costs and maximize revenues, right? So usually this is good for leagues that aren't very large already. In trying to promote the league itself, if the demand overall for the sport is relatively low, having every single team and every single owner's actions to be coordinated, right, and help improve the overall demand for the sport, well, that's going to benefit every single team more than if they were kind of making decisions just for themselves, like in a franchise league, right? So it's kind of tying in that it's addressing the fact that teams are all going to have different incentives and disincentives in order, to maximize their own profits. If we tie everything together where we're just maximizing profits for the league, this can really help the league grow initially. Right? So I believe the WNBA and then Major League Soccer, at least the last time I checked for Major League Soccer, I don't know if they still are kind of operating as single entity leagues. Right? And so there's, pros and cons to both. Like I said, usually single entity leagues or sports or leagues that we're trying to grow. Once they become large enough, they would likely kind of adopt more of a franchise model. And so all these are things that are related to the league decision-making. We're going to kind of switch gears a little bit. And I think I've alluded to this before, but I really want to try to go a little more in depth into thinking about surplus when we're looking at these markets. And so we've talked about monopolies. We'll kind of review a general monopoly market. So maybe this is like the apparel market where we have kind of these nice increasing marginal costs. We've got our demand curve and then a monopoly. So we've got this twice as steep marginal revenue curve. we said that the optimal quantity will always be where marginal cost is equal to marginal revenue. So at this quantity, we know we could get away with charging whatever price we would be at on the demand curve at that quantity, because demand reflects marginal benefit, and that's how much people will be willing to pay up to. Okay. So if we're thinking about the producer surplus that exists in a monopolized market, producer surplus is always going to be the difference between the benefits and the costs of the producer. Right? So you can think about what's the benefit to the producer. Well, that's the price they're able to charge. What's the kind of cost of the producer? Well, at every single one of these units, we have the marginal cost. So for every unit sold, the surplus would be the difference between the price that the seller keeps and the marginal cost that it took to make that. Then the next unit, the difference between the price and the quantity. Next unit, all the way down to that last unit we sold. The surplus gained from that last unit is the difference between the price that they receive and the marginal cost to produce it. So it's almost like we're adding up every quantity in this range, right? And that would represent total producer surplus, right? There's producer surplus made from each unit sold, but then there's overall producer surplus as well. And that's kind of the area underneath the price, but above our marginal cost. Okay. And if I had some actual numbers here, you can kind of imagine I've got a rectangle here and a triangle. I could calculate that surplus value. Okay. Consumer surplus instead is going to be the difference between the benefits to consumers minus the cost to consumers, right? So all of this is just benefits minus costs. So what's the benefit to the consumer? Well, the demand curve is telling us the marginal benefit, right? And the marginal cost is just how much they have to pay for this good. So the difference between the price that they have to pay and the marginal benefit of consuming that good is just going to be this little triangle up here at the top. Okay. And I'll give you some equations here in a second. I'll write them out. And then deadweight loss is basically going to be, because we have this, non-perfectly competitive market, how much surplus is lost because it's not perfectly competitive. Well, the perfectly competitive equilibrium, remember marginal costs, if we only have one producer, right? Our supply curve is like adding up the supply curves of every producer. But if we only have one, then the supply curve just is the marginal cost of that one producer. So you can think about here, this marginal cost curve is really just representing supply, because we only have one firm. So their decisions are made off their marginal cost curve. So that's going to tell us how much is supplied from that one firm. They're the only firm. That's aggregate supply. So really, the perfectly competitive point would be where supply is equal to demand. So my marginal cost is my supply curve. So we would have been out here at a much higher quantity under the perfectly competitive situation or scenario. So every unit that's not sold because of this monopoly power, we're going to lose out on the surplus from each one of those units. So you can kind of think about what's total surplus in this market. Well, that's just the difference between the marginal benefits and the marginal costs, right? So this entire area here is going to represent the surplus that was lost because we're not in a perfectly competitive market. We're in a market where a monopoly exists. Okay. So one way to kind of remember these differences between producer consumer surplus is think about producer surplus is going to be like, if we want to write this real formally, we're adding up from the first quantity all the way to the last quantity purchased, right? The difference between the producer's benefits, which is the price of the good, minus the additional costs that are incurred to produce that good. Another way of thinking about this is just looking for the difference, or looking for the area under the equilibrium price, but above marginal cost. Right? And consumer surplus, you can think of, go from the very first unit bought to the very last unit, and then add up the benefit to consumers, which is the marginal benefit curve, which kind of is represented by demand, minus the price that they're paying, or area under demand, but above price. Right? So that's one way of, two different, a mathematical kind of representation of what we're doing when we're calculating producer and consumer surplus from these graphs. but they're really, both of them are just the difference between the marginal benefit and the marginal cost. It's just that the price for producers is up here, is marginal benefit, right? Is the price for producers. And then the marginal cost is the price when we're looking at consumers. Okay. Any questions on that before we keep moving? Just kind of a little bit of review of consumer producer surplus, starting to think about deadweight loss. Okay. All right, so let's think about how this might apply to some of the markets we've been thinking about. So monopoly behavior is going to result in, we can kind of see from here, relative to the equilibrium under a perfectly competitive market, we know there's going to be higher prices and lower quantities, right? But it's not always true for ticket prices and the number of tickets. So we'll kind of start to look at ticket markets. So, maybe I'm okay with not making decisions based off of my monopoly power in the ticket market if I think that I can make up those profits in another market, right? So maybe I lose some money in the ticket market, but that in turn results in me making more money off broadcasting, selling broadcasting rights. So we talked about this a little bit, where there's kind of a link between these different markets. So how much money will these teams or leagues be willing to spend in order to maintain this monopoly power? So if they do choose to set prices and quantities based off of this, how much money would they be willing to pay to stay and have that monopoly power? Well, really, it's going to just be the differences between the profits that are made as a monopolist, because they know if it's in a perfectly competitive market, in the long run, profits are equal to zero, right? So really, the difference between the profits made as a monopolist versus the profits made as a perfectly competitive market. But the thing is, quite often, this is just going to be zero. So the amount that we're going to be paying is just the profits that they'd be willing to pay up to that amount, because at that point they'd be breaking even, right? So if I'm making $10 million, and in order to kind of create some barrier to entry to prevent other teams from entering this market, I'd spend $5 million, right? Because I'd still be up $5 million. If I don't spend it and other people kind of join the market and it becomes perfectly competitive, profits are going to get driven down to zero. So I'll pay up to whatever that amount is that I'm currently making. So by maintaining this monopoly power, these teams benefit, right? But consumers are hurt, right? Society is also hurt, right? We saw that there was a non-zero deadweight loss, which means surplus from this market is being lost. Okay, so let's think about what this looks like in the different markets we talked about, specifically the ticket market, thinking about surplus and monopolies, and then also thinking about maybe what this looks like with the optimal number of wins. Okay. So we've really already looked at this. Oh, sorry, I'm going to switch this over. We've really already looked at this, adding in monopoly power for these small and large market teams and thinking about the optimal number of wins. So we said, here's the amount, the marginal benefit to each win. Kind of here's my marginal revenue, which is twice as steep. And if I'm profit maximizing, and kind of think about, it's not that there is a price being paid like by one person for this number of wins, but it would translate, this number of wins would translate into amount of a certain marginal benefit across all revenue streams. Right? So you can kind of imagine, even though there isn't like a price being charged per win, right? There are prices being set for tickets, apparel, things like that, that would then translate to, if I have a certain number of wins, what is the price that I can charge for all these different types of goods, right? That are related to that number of wins that my team has control of. Okay. So it's kind of like, put a question mark, there's kind of a price here, right? There kind of is an equilibrium price, or at least there is an equilibrium kind of marginal benefit that this team is going to receive, right? The price that they're able to charge for winning this number of wins. And that price just comes through many different avenues, right? It comes through tickets, comes through apparel, comes through broadcast deals that are made from the league. And so we can imagine if that they didn't act as a monopolist, well, remember, marginal cost is really just another representation of supply. So the perfectly competitive point should be somewhere out here. The perfectly competitive point actually should be where profits are zero and where teams are win maximizing. When teams are win maximizing, all of this surplus that would have been lost if they acted as a monopolist and profit maximized, right, all of this surplus is kind of returned to the market if we can get teams to win maximize. Okay, so that's kind of how surplus is working there, right? Yeah. Any questions on that before we keep moving? I think there's anything else I want to say, just kind of relating surplus to things that we've already looked at. I'll wait for a second here. Okay. So the next thing that we can think about is the ticket market, right? So the ticket market, we're looking at the quantity of tickets and the price here. We kind of said in the ticket market, we've got this like L-shaped supply or marginal cost curve where then it becomes vertical at wherever our capacity is. There's no marginal cost to providing an additional seat, like the seats are already there. And so it's really just, marginal cost runs along zero and then shoots up, right? Because we can't sell anything past our capacity. You could then think about, let's say I've got demand and it's really high, right? And then I've got my marginal revenue here. So if this is the scenario, the perfectly competitive point would be right here, right? Where supply is equal to demand, right? Well, so we'll call this the perfectly competitive quantity. And what's the price that gets set? It's going to be right here. Well, what's the optimal quantity and price for the monopolist? Well, marginal revenue is equal to marginal cost here. So we end up with the same quantity. And we know that consumers will be willing to pay this amount. So we actually end up with the same exact price as well. So with the ticket market, if demand is high enough, it's really from like looking at the data, if the capacity of the stadium is relatively low, we can't actually tell the difference between whether or not it was a perfectly competitive or monopolized market, right? Because the optimal price and quantity to set is going to be the exact same, okay? Now, if we go to a different scenario, so let's say that demand was much lower, right? I'm kind of being very exaggeratory here. So we'll call this kind of a different set of demand and marginal revenue. Well, at this point, the perfectly competitive point is way out here, right? Where demand hits my supply curve, right? So this is going to be a perfectly competitive quantity. And then we have this weird scenario where the perfectly competitive price is zero. However, for the monopolist, marginal revenue is equal to marginal cost down here. And we kind of think about, even though they're not charging, you think about what price can they charge for the tickets. Well, consumers would be willing to pay whatever point we're at on the demand curve. So under this scenario, right, in the ticket market, we would see higher prices and lower quantities. So if demand is lower than capacity, we kind of get our traditional or our conventional outcome, right? However, if demand is high enough, we could lead to a situation where a monopoly and a perfectly competitive market, actually we end up with the same quantity of tickets and the same price. There's absolutely no deadweight loss. Well, if demand was lower, right, what would deadweight loss be? Well, it's all the surplus that we lose out on by selling a fewer number of units, okay? Or a fewer number of tickets in this case. Any questions on that? Okay, so one thing that's kind of weird to think about is the additional revenue, if demand is high in the ticket market, so this is specifically to the ticket market here, demand is high enough, the marginal revenue of that last ticket sold is going to be positive, right? And that makes sense. You'd think like, when would I ever sell something? Like, even if my costs were zero, if the additional revenue ever becomes negative, even if my additional costs are zero, well, there I'm just losing revenue. Why would I continue to produce that high? Well, I was like, here, we can kind of see for a perfectly competitive firm, if they acted like a perfectly competitive firm, we would actually end up, I mean, that last unit sold would actually have a negative marginal revenue associated with it. Now, this point, you know, is going to be essentially we're setting a price equal to zero, right? And so because our costs were running zero here, maybe every additional kind of unit here, if we were to choose different prices, marginal revenue would be increasing. But if we were to choose this price here, we'd actually be at a point where we've gotten the marginal revenue of the last ticket sold to be negative. Now, profits would still kind of be equal to zero in this market, right? My price and my marginal costs are zero here. So if the additional revenue and the additional costs are zero, my profits will be zero. I'm running at zero. Whereas it's here, I gained some revenue from these units, but then I lost that same amount of revenue by selling up this higher number of units. So we've got kind of differences in monopoly behavior, how it leads to a loss of surplus depending on if demand is high or low, right? Or above or under capacity might be a better way to say that. Okay. Any questions on anything so far? Okay with this? Another interesting thing to think about here. Okay. I wasn't planning on doing this, but I think it's interesting. So let's say that we had really high demand. So maybe my capacity is like right here. I've got really high demand and really high. And let me draw this again. I was trying to make it really big, and I think I'm gonna. All right, so let's say we've got. Here's my demand curve. Twice as steep marginal revenue. Okay, that's what I wanted to do. And then maybe my capacity is somewhere here, right? So supply, marginal cost, or capacity here. Okay. And we know that the monopolist, will choose the optimal quantity where marginal revenue is equal to marginal cost, and then the price per ticket from that monopolist will kind of end up here. So there's no deadweight loss here because the perfectly competitive point is exactly the same. What's kind of interesting is if I'm a monopolist and I'm thinking about the long run, in the long run, I can change capacity. I can renovate my stadium. I could, move locations. And so what happens if instead we're somewhere like this? So I move to this new stadium with this new capacity, and it's higher. Well, now where's the optimal point? Well, now the optimal point, remember, my supply curve runs along this x-axis up to that vertical point. And so here, the optimal quantity and price would be here for the monopolist. But if it was a perfectly competitive market, supply is equal to demand out here, we actually have some deadweight loss. So in the long run, by choosing capacity size, potentially teams, we could go from a scenario where there was no deadweight loss in the market to under this new stadium, we actually see that there is somewhat deadweight loss in society, as opposed to if, a different price and quantity were set for this new stadium. But maybe it was good for the team, right? So it must be, if they made this decision, you can think about it would have to be the case that this total revenue in this market would have to be less than the total revenue made after we made that stadium shift. Right? Oh, sorry. And not only would it have to be that this total revenue is greater, it would have to be that this additional revenue minus, whatever the additional costs are to building or renovating that stadium, right? It would have to be that is larger, right? Whatever the difference is between my old and new total revenue, I'd pay costs up to that amount. But if my costs ever went over that amount, well, now I'm not making more money than before. So we could see a scenario where this does hold if they're on the right kind of point of that demand curve, if the elasticity is if they're at a elastic point on the demand curve, then they could potentially increase quantity, right? Increase capacity, increase quantity, and make higher additional revenues. But it has to be that the additional revenue they make, that the costs aren't greater than that. But if it was that scenario and they moved to this new stadium, maybe we go from a scenario where there was no deadweight loss to where there actually is now for society. So it's kind of easy or interesting to think about some of these things, and some of these questions or situations that the team's going to have to deal with when they're thinking about moving to new stadiums or renovating their stadium. They're not really concerned about this deadweight loss to society. They're really concerned with, will the cost justify the additional revenue that's made? Right? Okay, so we looked at the ticket price market. And we've already talked about this. It could have this weird scenario with monopoly power where we actually find the optimal point is where marginal revenue is equal to zero, but then they can charge a price, right, going up to the demand curve that is positive. So sometimes we'll see teams operating at this point where marginal revenue of the last ticket sold is zero. We found that a lot of studies are actually operating, there's some studies that find that some teams are actually operating at negative marginal revenues. The only way that this really makes sense, right, is if the losses then we, in profit we start to experience in that ticket market, if we can make up for it in other markets, right? And so this is the idea that, let me see where we had it earlier. So maybe I choose this point here, right? And that's because when the stadium is this empty, nobody wants to put that game on TV. But if the stadium's at like half capacity, it's not as bad of a look. There's camera angles, right? And so it's more attractive to be able to sell those broadcasts, right? So if I do kind of lower the price and sell a high number of tickets, well, maybe that loss in revenue in the ticket market, because I have a fuller stadium, I can make up for that in other areas. And I said broadcasting, like concessions and things like that would also play a role, right? And so that's why sometimes we see teams choose to actually go to a point where marginal revenue is less than zero, especially when it comes to teams who are under capacity. And you might have heard this terminology in other classes. So I think like in a general context, we say like sometimes people will have loss leaders, right? So I offer a discount on, I don't know, when I was a kid, I remember this one store that just opened and they did this special 25 cents for a gallon of milk, right? Just hoping to get people into the store, and then they would buy other things that were overpriced and they'd make up for the losses on the milk, right? So that's the idea here. Even if I lose some money on my tickets because I have a lower price, I can make up for it in my higher priced items like concessions. Okay. All right, just double checking the chat here. So I'm then going to start talking about some types of discrimination. When we talk about price discrimination, this isn't generally the way we think about discrimination in terms of like based off of some personal characteristic like race or gender or something like that. It's more so price discrimination based off of the willingness of people to pay, right? So all the models we looked at up to this point, like for monopolists, are really single price models. We've assumed that they can only charge a single price for whatever good we're looking at. So in the ticket market, that gets a little interesting because we're going to be basing that price off of individuals who may have wildly different demand curves for tickets, right? Different slopes, maybe different starting points. And so it might be that there's different prices I could charge different groups. And when I say groups, this could be based off of like not characteristics of themselves in the terms of, like I said, race and gender, but more on their willingness to pay. So if we want to allow for firms to vary their price, we can kind of lead to scenarios where we see an increase in profits. So you'll see a lot of teams, or you'll see a lot of companies do this where there's student or senior discounts. And that's because we know that students and seniors are on what we call fixed income, right? They have a relatively low income, right? And so their willingness to pay, right, decrease in income, if we believe that tickets and some of these other things are normal goods, right, then we should see a decrease in the demand curve. And so the optimal price to charge a student or a senior is actually going to be lower than a non-student or non-senior. Okay, so if we can somehow target specific groups that we know on average have lower overall income, we would want to charge them a lower overall price because we know they have a lower ability and willingness to pay. Right? They just have a lower demand curve. So if we can, legally, identify groups that, like students and seniors that have a lower ability to pay, we would charge them a lower price, and that would actually optimize the number of tickets, or the total revenue, total profits made. I shouldn't say total revenue. That would optimize the profits made from selling tickets to students and seniors. Right? Sometimes different times will have different prices, right? So we know that people aren't as willing to go eat dinner around 3 o'clock, right? And so, maybe we offer different prices within different hours because we know the groups that would eat dinner during those hours tend to be older, like the early bird special, right? Or happy hour, kind of targeting younger individuals drinking earlier in the day when maybe typically demand isn't as high there and people aren't as willing to pay as much for a drink during those time slots. Right? So all of these are examples of price discrimination where we're charging different prices for the same goods, selling the same tickets. I'm selling the same, drinks or food here, but I'm trying to kind of identify that at different times of the day or different groups of people have a lower overall demand curve. And in order to maximize profits, I want to allow that price to vary with those characteristics. There's a lot of minor league teams that do specials like that too, like on weekdays when it's harder to get people to come out to a minor league game. They will offer like insanely low ticket prices and things like that. So it may vary with the day of the week as well. So this idea of price discriminating, kind of more so the last examples I was giving you, is really going to be this idea of variable ticket pricing. So we know that there's a lot of different factors that impact demand and consequently marginal revenue, specifically in the ticket market, right? So if you think about the demand for attending a game on the weekend is likely much higher than that for a game during the middle of the week, during the middle of the day even, right? If I had a job, right? So it's hard for me to do that. And so we've got basically these ticket models, right? But this demand curve is going to be changing for every single game, right? The quality of the opponent, the quality of the team, day of the week, time of the day, all these things will factor into that demand curve. And so as that demand curve increases or decreasing, my capacity is staying the same over the season. And so that's just going to predict different optimal prices for different games. So this idea of variable ticket pricing says, well, yeah, I shouldn't be just setting the price for a ticket for every game across the entire season. I should allow this to vary with these characteristics that I know impact the willingness of people to pay, right? Or impact my demand curve. So variable ticket pricing, you try to do this kind of ahead of time. You try to look at all these characteristics and these factors and try to predict, right, where demand is going to be at for all these different games. And you do this kind of ahead of time, right? You can buy tickets at the beginning of a season, right? And even at the beginning of the season, they all might look different, right? It might be different prices for different games, depending on when they are, who they're playing. And so a couple of teams have adopted this and really just been pretty transparent. So my favorite that I have found an example of is the Buffalo Sabres had basically different metals, right? Platinum, gold, silver, and bronze. And they labeled each game as that, right? And I forget what the value games was thing, but basically like this is just identifying the differences in quality of the game, not just quality of the opponents, quality, of the time of day, of the day of the week. And so they knew the platinum games were going to be ones that were way more likely for people to be interested in than their value games. And I do this at the beginning of the season, and then prices are kind of based off of this classification. You'll see, during even at the beginning of the season for college basketball, if you look at the ticket prices, even for your good teams, maybe you could probably go out and Google it, even like Duke and Kentucky at the beginning of the season. Look at what their prices are for games in, say, a weekend in February versus a weekday during winter break, right? So if you look at the ticket prices for winter break NCAA basketball games, they know demand is going to be much lower. They're, first of all, missing a huge number of consumers over that time usually. And so they're facing a much lower demand curve. And so you'll see those ticket prices tend to be much, much lower, right? So like I said, beginning of seasons, you can go out and kind of see how teams are actually using this variable ticket pricing. Dynamic ticket pricing is a little bit different, but the same idea. So you still have all these factors that you know will impact demand for a game. However, you don't know it at the beginning of the season, right? So, you know, players have unexpected, good seasons. Maybe they have some injuries, pitchers, right? You're not sure exactly when they're going to play. So it's very relevant in Major League Baseball because let's say I have, typically a 4 or 5 man kind of rotation. So every pitcher only pitches every five games. But things happen during the season where, maybe one takes a break 1 week and, the ordering gets kind of, mixed up a little bit, or we've got a couple days in between these games. So, I actually, my pitchers had 5 days off, even though it's only been 2 games. And so I'm just going to, start pitching them again. And so it's kind of hard to predict exactly when pitchers will be pitching which games at the beginning of the season. But as the season goes on, within a small window, I know who's going to pitch the next 2 or 3 games, right? Or however many you look at, right? And so dynamic ticket pricing allows for me to adjust for all these factors, right? So for instance, I'll give you a good example, very recent. So the Golden State Warriors are pretty one of the top kind of value teams by Forbes at the NBA. They're very successful, but right now they've got a lot of injury issues. And the other night they played a game, and I think it was like 4 of their best players were sitting out, right? So almost their entire starting lineup. Excuse me. And I have got to imagine if the team was trying to maximize profits by selling tickets for that game, if they had any tickets left, they were probably using dynamic ticket pricing, which was they started to adjust the ticket prices for that game where, the entire starting lineup was going to be out. Not a lot of people would probably want to go pay to see kind of the backups. And so they probably lower the ticket prices immensely, right? Because they know that if they kept them high, they just weren't going to be able to sell the remaining tickets they had, right? And so basically dynamic ticket pricing is just variable ticket pricing done throughout the season, right? Reacting to some of these things that you can't predict kind of the timing of at the beginning of the season. So Major League Baseball does this a lot. And it's really because they just have more things that factor in. So like NBA doesn't have to worry about weather. Major League Baseball does. People don't want to go sit in watch a game if it's raining, even if they don't postpone it. And so, or if the weather is supposed to be bad, some people might not want to even take a gamble of buying the ticket to go to the game. I already mentioned kind of the pitcher rotation plays a role. So, but we really do see this across every league. And they're very similar. Dynamic and variable ticket pricing are very, very similar. Okay. Any questions on that? And, to draw like a graph of this, really all you're thinking about are shifts in the demand curve because of all these characteristics. Okay. All right. Any questions before we keep moving here? I think I'll save bundling for next week. And we'll kind of revisit some other pricing strategies as well. But for now, I want to try to look at this paper that I kind of had up there. Right? And I believe one of the questions on the online quiz, and this is what I'll kind of start doing with those online quizzes, having at least one question be related. If it's an online quiz between Tuesday, Thursday classes, one of those questions related to the paper, I want you to at least skim. And I believe the way that I wrote the question, you could have read the abstract and got it correct, right? So the abstract really tells us here what this paper does, which is it uses some older data, 80s and 90s, but it finds that player performance improved the year before they signed a multi-year contract. So kind of in the last year of their old deal, right, where they're trying to work out a new deal, we see an increase in their performance. Right? And that kind of lines up with, well, there should be an increased incentive to perform very well when you're trying to kind of go out and sign a multi-year deal and in the last year of your contract. However, it found once that they sign one of these big multi-year contracts, that their performance in the following year, like, so they sign it in the off season, that next season after they sign the deal, they actually see performance declines. Okay. So, you know, what does this mean for teams? What does this mean for players? You know, if I'm thinking about this, then maybe I want to sign shorter contracts, right? So that there's always this increased incentive for players to do well because they're signing new contracts kind of every year, every couple of years. Okay. Now, you know, that whether or not that'll happen, right? There's bargaining going on in both ways. And so for the player, there's always a benefit to having a longer deal, more guaranteed money, kind of more security is not the word I want, but you know, it gets a good idea across. And so how do they actually come up with these results, right? So we'll scroll down. We don't have to necessarily read all this because really, like I said, what we're always concerned with, getting close to it, I think, maybe not, maybe this paper's longer than I remember. So here's our summary statistics. So this tells us a little bit about the data. So they got about 26,000 observations, right? We'll come down here. There's what I wanted, right? So there's my regression equation. So Z here are going to be different features of the contract. So I believe this is things like contract length, contract, you know, the value, the actual dollar amount of the contract. And so yeah, length, total pay, average annual pay. And then how does that contract depend on these other things, right? So we've got P bar here, which is the historical performance of the player prior to the contract, right? So I believe they go back 2 years. So they're not including the year right before the contract was signed. They're looking at every year before, prior to that. And then the change in P here is how much change was there in the contract year from their performance in that contract year, like right before they signed the contract, and the difference between that average performance. Okay. And then they control for things like the player's age. I think that these are position. So one thing that we'll see used a lot in this regression analysis, and you can kind of do this for your project as well, is, so I'm thinking about here, I think they call it Z, right? And I've got the intercept. What I could do is start to include things for positions. So, and this is NBA. I don't know if I mentioned that already. So they were looking at NBA players. So maybe like something that I could do is just create identifiers. So all these would just be 1-0 variables for what position the player will play, right? Guard, forward, or center. Now, what I'd want to do here, I would probably do something like shooting guard, because if I ever include indicator variable or dummy variables, or what they're often called, for like a category, right? This is a position category. I have to leave one of them out. So the one that I leave out is like my reference point. So now the coefficient on shooting guard would be relative to the position I left out, which here I was thinking like I left out point guard. So relative to a point guard, a shooting guard, we would expect their contract to go up by whatever that coefficient is. So we always have to leave out one group. But one way that you'll see this written in papers is here, you're just including identifiers for what position the player played, identifiers for where's the team they played for, and then identifiers for what year the contract was signed, right? So that controls for like the fact that we have inflation and things over this entire time period. So they're first going to do that. So they're going to try to use these performance measures to predict what type of contract these players get, right? So we'll go down here, we look at the table, and the contract value, the contract length, and kind of the average yearly salary that the contract kind of translates to. If we look at, excuse me, they've got different statistics, but they've also done some regressions where they used all these statistics to come up with one nice continuous measure, or this composite rating. And as this goes, composite rating goes up, that kind of would translate to like higher performance in some of, one or several of these other categories: points, rebounds, assists, blocks, these other statistics. Okay. So we can kind of think about here, this all makes sense, right? So it's all these coefficients we can interpret as, so each column is a different regression. So for here, our dependent or our Y, our left-hand side variable that we're trying to predict is contract value. If a player on average scores one more point per game, that might not be true. It might be total points. One more point during the season, it probably makes more sense. So if they score one more point on the season, their contract value goes up by what, 4 cents? Well, that makes sense, right? Because I mean, across the entire season, scoring one additional point might increase my contract value by 4 cents, but I'm scoring hundreds, if not thousands of points, as well as getting rebounds, as well as getting assists. So all of these are going to be kind of the impact of one more point, one more rebound, one more assist. Now, this composite rating would be that if it goes up by 1, and I forget exactly how they kind of came up with this composite rating, right? But if my performance goes up by 1 unit of this composite rating, my contract value also goes up. And you'll notice here, like everything is significant, pretty much. Looks like blocks aren't. So maybe blocks aren't being rewarded very much with contract with dollars. Right? So here we've got statistically significant. So it must be that the p-value. Oh, hold on. I just lost my light here. There we go. So lights went out. Sorry. So we could see here that, performing better leads to higher contracts, right? That's not insane, right? And that's my historical performance. And then here was that kind of measure for, well, what was the change in my performance in that year right before the contract? And the historical was like 2 years prior and everything before that. Okay. So they both have, both those performances have positive effects on my contract value, both have positive effects on my contract length, and both have positive effects on the kind of average yearly salary that the contract translates to. And kind of the same thing for points here. Now, it looks like some of these performance measures, maybe contract length isn't tied as heavily to some of them. Also notice all of these, the value, the length, and the average annual salary, as the player gets older, that decreases the expected contract value, length, and salary, which makes sense. As players get older, typically their performance falls off and they're not as likely to be able to command as high of a valued contract. Okay. So that's kind of our first look into this, right? But really what's more interesting, I think, of this paper is they then say, okay, we're going to actually look at performance as the dependent variable. And we'll see, does performance change in the year prior to a contract being sold? So here, pre is just a 1-0 variable if it's the year right before the contract was signed. And then post is going to be a 1-0 variable for, was it 1 year after the contract was signed? So here, my units, if I've got a 1-0 variable, I can't go up by, 1 year of age, or I can't be 1 more point on the year. Here, a movement of 1 unit is going from the group that was a 0 to the group that was a 1. So relative to not being in the year prior to the contract, if I'm in a year prior to the contract, beta, PRE is the expected increase in my performance that I would expect from being in that contract year. And then post, same thing, relative to not being in the year following signing the contract. If I am in the year right after I sign the contract, beta post is the expected increase in or decrease in performance. And then they control for age and all those other things we mentioned earlier. Okay. So we then come down here and they did a similar thing. They had these performance measures. So they had points, rebounds, assists, and blocks. And then there's some other things, minutes played, shots attempted. But they also created this composite rating that was trying to give one value that represented the quality of the player. Okay. So it's a little bit hard to understand exactly what the increase in the composite rating translates to, but we'll just think about direction here. So first of all, if we look at in the year prior to the contract, like being in the last year of my contract, right, I'm going to have to sign one in the off season. The composite rating, if I'm in that year prior to my contract, we would expect it to go up by 0.38, and it's very significant. We would expect the points scored, and I'm guessing if we go back up here, maybe I was wrong, this might be points per game. So if we look here, here we go. So points, the mean of, so this must be points per game, right? So if we go back down to table 3, the points per game increase in that kind of year prior to my contract goes up by almost a whole point, right? 0.8. And then rebounds goes up by about 1/3 of a rebound, assists by about 1/10, and block shots by about what, 1/20. You notice that they're on the court for a higher number of minutes over the season. And I guess they ended up getting more free throws. So this must be maybe they're just more aggressive, right, in their play. So all highly significant, right? And that's holding constant player's age and all those other indicators that they included in the regression equation. They just didn't show you in the table. Right? And then, so that's interesting, right? So what this is saying is that because I'm in that last year of my contract, not saying that players, maybe even consciously do this, but it must be that there's that increased incentive, right, for them to really perform well this year because they need to sign a new contract. They want it to be as good a contract as possible. We see performance in that year increase. Now, in the year after a contract is signed, the interesting thing is, first of all, we see a lot of the significance go away, right? So once I've gotten this huge contract, right, you would think maybe I'd be, if I wanted to tie some moral kind of benefits to it, maybe I want to reward the team that gave me this huge contract. Maybe we would see these be positive, or maybe I'm feeling like, whew, like what a relief. Like I've got this 3-4 year contract now. I don't have to worry about losing my job. And so maybe I slack off a little. So what they see here is for that composite rating in the year right after a contract, there's a decrease in performance, right? Now, in any one statistic, all of these, we can't say that they've changed other than rebounds. Looks like it goes up, but everything else, even though they're positive values, there's no stars here. And, these values that they're putting down here in parentheses represent the p-values. None of these p-values are less than our kind of benchmark values of 0.1, 0.05, and 0.01. Okay. So no real strong evidence of changes in that year after the contract is signed, but some evidence that in the year right before they need to sign a contract, we see this kind of increase in performance. And we can scroll down here. Here, I think what they did was looked at composite rating as the performance measure. So what is this? The link between contract. Okay, so that's so they showed us on the previous one. But they took this column, they ran that regression again, but they started to try to throw in some additional kind of controls, right? So they had age squared that tries to pick up, is there like a non-linear relationship? They then kind of end up at this point at the end where they say, well, what if they get traded, right? So if they're traded to a different team of the year, what would this be? Yeah, if they get traded, what kind of change do we see in performance? And we actually see that there's a decrease in performance if a player gets traded, but controlling for whether or not that player got traded kind of increases that estimate just a little bit, right? And including these additional controls are really what matters, right? If we don't control for the year, the team, or the position the player plays, then these are pretty insignificant, right? They also do some things with weights here. We don't need to worry about that. That's kind of outside the scope of this class. But kind of the end goal, the end result is once I have all my controls in, so right, Y just means yes, all these controls were included on the right-hand side, then I end up with the kind of the same kind of thing. I see a decrease in performance after the contract is signed and an increase in performance right before that contract year is up. And I believe that's their only other table. Oh, they might go, they do some interaction stuff, which we don't really have time to kind of dive into today. I actually might pick up on this. We might revisit this paper next week because I do at one point want to kind of show you or talk to you or discuss how interaction affects work in regression. And when we're reading these papers, why that there might be some really useful information that comes out of it. Okay. All right. So a little bit of linear regression review today. We got in some good kind of pricing stuff, talk about monopolies and surplus. So obviously we didn't get through near all the slides I had in here. I put a bunch in to be overzealous. We'll probably get through the rest of these slides and then some additional slides next week. Let me see, I can see me as I'm signing out here. So we'll kind of pick up here next week. You've got your homework, which is due next Tuesday. You can turn it in class, or you can upload it to Canvas. So either way, I'm okay with. If you are going to be in class Tuesday and it is done, it is easier for me to have a hard copy. But if you need to upload it, that's okay as well. Other than that, I won't do an online quiz from here to Tuesday. I'll kind of give you guys the weekend to make sure you're finishing up, wrapping up that homework. And if you have any questions, feel free to reach out to me. And other than that, if you wanted to talk to me during office hours, a couple people reached out today. I will do them via Zoom since the weather's crazy. And hopefully next week we'll kind of be back to normal with those office hours. Okay. All right. Are there any questions before I sign out here? Good. All right. Everybody stay safe out there, hunker down, and hopefully, like I said, hopefully we'll see you next week.